Okay, so um, the sim is finished. I did a little bit few changes. There's also one thing I want to mention in the previous video, but I couldn't. So I think it's this one. Flip configure flip. So if you drop this node, it's kind of already building you um, how this is being used. And then there are other options like you see there's like a several presets that is very useful. So I guess you could use a flip configure beach tank, flip configure ocean layer. I think this is the one that we could work with. There is my version is a bit more simplified. It works um, a bit more simple, I guess. But if you want to observe how these tools are being built, so you can do your own exactly, please do check all these. There are all these configure ones. These are very, very useful from side effects flip configure, lava, pyro, and they just drop the the not this one. They just built this kind of network for you. But having said that, this is our current result, and it's working. I think to my taste, maybe our waves are a bit too big, but that could be because of the low res simulation settings as well. This is not cache. I think cache I just made a flipbook. Um, so there's a couple things that I want to continue before finishing this version. Now we want to cache this out, fluid compress. So we're going to build the entire network and then kind of like finalize the output later on. The particle separation should be linked to here. Paste. Okay. And let me double check. And basically now I'm gonna drop a null. No, actually we already have our null. Let's do this here and let's call it flip sim. So where do I cache this out? So the way I'm working with the tops is that I'm gonna drop here a file cache node. I'm gonna name this BS. Actually, I don't need to do that because I'm in the heap. So I'm just gonna call this flip. And however, what I do here, I will change base name to just $OS, and this will stay as it is. Now, in main object level, I'm going to create a top network, and I'm going to name this sims, or whatever you want to call it. And in here, our very first thing is a rough geometry output. Okay, I'm going to call this sim flip. Now, what I'm going to do is, because of simulation, I'm going to say, let me make this a bit bigger. This is going to be automatic. Now, the sub path is going to be this null. Now, this is the twist part. I'm going to open the file cache because this generates a name and it can be found under advanced and path. So basically, if I extend this, so it's resolved into this, right? If I change the version, it's going to change into version and so on and so forth. So I'm going to take this output file and I'm going to paste it here, okay? Which means the output from topnet is going to go exactly where this node is expecting it to read it from. I don't know if it was a sane sentence. Okay, so what we're going to do now is that I'm going to change this resolution to something a bit more high res, and I'm going to send this to cache. Um, Maybe before I do that, what I want to do is, let me see if my HQ is running at the moment. No, let me run my HQ. That's gonna be with my command lines here. Okay. Now that should be working. Now, in fact, let's do this a little bit more fun. Let me bring here my help browser, and let's type in that address in there. So we have our internal. That should work, right? Oops. There you go. It's just not the size I would like, but it's there. Wish they had more control on how this works. Okay. On next thing, and we're gonna set this up properly. So I guess HQ installation. So installing HQ is fairly simple now. If you are using Houdini Launcher, which I do, it allows you to install out of the box for Windows and Linux alike. It's very, very simple. The setup process, however, is a little bit more complex, especially my situation when because I'm using two computers. Let me open this up on my other Houdini. So we're gonna kind of like do it the same way here. I'm gonna so put this on one half and put this on the other half. Um, I don't need that. I don't need that. So we have the space. Now I am storing, and I didn't have to do it that way, but I'm storing my schedulers here. So I'm going to copy these schedulers, and this is basically telling how HQ should be doing how PDG should be tasking machines on the farm. So I created a HQ scheduler, several different ones. Workstation one is because my machine is stronger, so the main machine is stronger, so I do the sims on this one. The other one is an older version. It's still a good machine, but it's mostly for I use it for all the heavy sims. I use the workstation on. So how does that work? Now, if you do drop an any HQ scheduler, it's gonna come by default like this. So when you run your when you start your server, it's gonna be, I believe, localhost 5000, which is this one. So if I think click here, it should open it. Yes, so that's the default settings. If this is where the HQ server is running, and most of the time for home use, it's this is how it works. Now the things that I had to do is, because I only have one copy, I am pointing it to my directory, and you can do the same thing for your Windows if you're on Windows as well, right? So, and then the other thing that I'm finding it that it works a bit better is if I say like the messaging queue is local, because sometimes there's a lag. I think the farm one, well, it can go to the other machine and then kind of like drops. Job parameters is where you select how this scheduler points. So sends the job to. So client. So I have two clients. Make sure the HQ server, it is running. Okay. Uh, what happened? Well, it is here. Okay. maybe I broke something. No, this is here. That's working, and that should be seeing the clients. This is the type error. Okay, make sure that they or change the value of HQ server. Okay, I guess there's always a surprise. Well, I can get that fixed offline to see why it's not working. Oh, maybe is that because no, that's maybe from here. Does it work? It does. Okay, it's just the name, I guess. It decided not to work, so we can do it that way. For some reason, it's not seeing the render node. Okay, so if I do that, select this guy, go back to job farm, select clients. Okay, so I have two clients, and TriSquad is my sim machine. And I dedicate that one to a HQ called workstation node. So this one is only going to select the listed clients, and it's allowed to run the whole thing. I increased the connection timeout and retries. It kind of solved a lot of other smaller problems. The other thing that you need to make sure is, I think this is all explained in the documentation, of course. I'm not going to go one by one. Let me see, it's not here. It's the shared folder portion of the work is extremely important. On my Linux machine, this is basically where all the data is being written. On both computers, it's the same place. That's basically the only thing that it required to make sure that it works. There's a lot of firewall things that needs to be done, but I guess that's like a whole another level of tutorial. But there are a lot of free tutorials on YouTube on how to set up HQ. So I suggest you guys follow that up. But now, basically, I know that this is going to send this to my machine, so I can select my ROP geometry node and I can say, use this guy for this work. Now, if this was a meshing, I would use both. If this was, both of my computers could do the meshing. Um, Now, the good thing is, if I put another node under here and call it meshing, let's say, which we'll set up that later. We're just gonna do a little bit of a update. And I could then say, you know what, for this one, use both. And this would trigger meshing of the simulation as the frames come out with this setup. So you wouldn't have to wait. Like it will be like machine one is simulating, machine two is actually meshing. And if you have more machines, it does it even faster. So you can end up seeing the result instead of the particles. But we're gonna come to that later. Okay, so this should be all good. And let's see what happens now. I'm just gonna save this. You can go to the other screen and right click, cook, save the invalid scheduler not using network default. Oh, okay. Cal, I don't know why it's saying invalid. Let's do it again. I'm gonna put this. Actually, that may have been the reason why I kept them in here. So I'm just gonna try it in here just in case. Okay, let's try it again. Go back to our topnet. I'm gonna get rid of this. Find the scheduler in the tasks. That's gonna be workstation. Accept. Dirty this node. Cook this node. And now the job appeared here, and just we're gonna let it cook. Oh, well, I didn't change the resolution. So cancel. That's gonna kill the job here, I believe. Yes. Let's go in water sim. Particle separation. Let's make it 0.5. I think that should do. And let me double triple check this. Come on. Okay. Go to the first frame. Flip solver. Let's see how many points. 0.05 is 5 centimeters for a ship this size. I guess that's a fairly reasonable resolution. Okay, it's going to calculate the initials. That's 14 million surface points. That's okay. The only one thing that I am not very happy is, okay, I'm going to drop the resolution so we can continue testing it a bit better. I'm going to do this one, so 10 centimeters. I think our spectrum is too strong. It's creating too many small waves. So I'm going to actually reduce that. And it's coming from merge spectra. So I would like these to be maybe 0.5. Maybe this could be like 200 as well, so it's not that sharp. Let's double check now. Yes, it's a bit, I think it's going to reduce, it's going to create a less problematic or less splashy surface. All right, so let's check. We're going to work on low res until we completely chain, and then we're going to up res it to kind of like uh, run the entire network. Okay, so back to here. Dirty this node, file save. Right click, cook. All right, and I'll see you in the next video once it's done.